Okay, so let's talk about wastewater, or any water going down your drains. It could be your shower, it could be your kitchen sink, it could be your toilet, and the waste that goes out of your house and into the sewage system. Alright, some people have an on-site septic system where you have a tank that's buried in your yard, which leads to a drain field. We'll talk about that at the end of this lecture. But what I want to talk about first is what happens to the wastewater. Anything that goes down a drain, anything that washes into a storm drain on the street, it all goes to the same place, the sewage treatment plant. We're talking about wastewater and what happens when you flush. Alright, a lot happens when you flush. Okay, that's all wastewater. It needs to be treated before it goes back out into the environment. Okay, it could be contaminated with all kinds of things, including coliform bacteria, anything you flush, anything that washes off the streets, the oils and the antifreezes, the things that drip out of our vehicles on the streets, everything that's considered wastewater needs to be treated before it goes back into the environment. It goes to the wastewater treatment plant. These will always be located near creeks, streams, or other bodies of water. Okay, some of the ones along the coast are linked to the ocean. Alright, this one here, you see a creek in that area of trees in the picture. These will always be located next to a water source because the water literally goes into the treatment plant, it gets treated, and then back out into the environment, into a creek, stream, or river, or body of water. Alright, there's 4 processes to this treatment. There's preliminary, primary, secondary, and tertiary. We'll go through those together. Okay, and this is a nice image from your textbook, and we're going to go through each step of the way. You can return to this image if you like later and review or study, but this one's a little bit more in depth. We're going to go through it together in a series of pictures. So let's start here at preliminary treatment, the first step of the way. Now, when you flush your toilet, the pipes in your house from your shower go outside your house and into the public sewage system. That system travels underground in a series of pipes, sewage pipes, and as it's going through town towards the treatment plant, those pipes are cut off from oxygen. There's no oxygen in those pipes. So our wastewater is on its journey in an anoxic environment. As soon as it gets to the plant, it enters preliminary treatment. So you see it going in this concrete walled structure here and under that little tunnel. Okay, that's the first time that the waste actually hits the oxygen environment, the oxygen atmosphere. So it's very smelly. By the time it comes out of these pipes and hits preliminary treatment, it's first hitting the air, and that's where you get that really terrible smell of the sewage treatment plant. A lot of people think it's somewhere else along this path of treatment, but it's not. It's right here when we get in. And those of you who are going on our field trip to the Telford wastewater plant, we will walk over this area and you'll see it and you'll smell it. But this is preliminary treatment. All right, this is where the water is actually going in to the treatment facility. And you see the amount of water there, and you see that the amount of water actually rises and falls. Okay, so depending on the day, depending on the time, depending on how many people are flushing and using water at once, the level of the water here rises and falls. So now think about a time like the Super Bowl, when everybody is watching the game, everybody's having parties, but what happens at the halftime show? Some people like to watch halftime show, most people don't, so everybody right at that first commercial to halftime quickly goes to the bathroom. So you have millions and millions of people going to the bathroom at once. So let's take all of Souderton. Let's say all of Souderton's watching the game and they all flush their toilet at once, and what we're going to see is the level of this water get very, very, very high, and you have this influx of sewage, influx of what we call effluent. Effluent is another word for sewage. Effluent. Water that needs to be treated. Alright, so all this effluent is going into the system at once. The system can handle it. The only problem is it doesn't clean it as much as it can. Alright, we have to accelerate the process, which doesn't allow treatment to its fullest extent. So in times like that, the water that goes back out into the environment isn't as clean as we'd like it to be, but that's a product of that time, of the Super Bowl halftime show, or Super Bowl Sunday. So it's just an interesting fact there for you. Let's continue on about preliminary treatment. Alright, this is preliminary treatment, physical treatment. Okay, anything that goes down the drain, gets flushed down a toilet, washes into a storm drain, needs to be filtered out. Those things cannot go through treatment. So they'll get stuck at preliminary treatment on something called a bar screen. All right, the water is passing through this bar screen, and this thing here, what you're looking at, that bar screen, will typically go down into the effluent. It's actually risen up here in this picture, but it goes down into the effluent, and it'll catch all those big things that should not be flushed down the toilet. Things like, let's see what's in this picture. It looks like an orange peel here, or it looks like a plastic bag. Maybe things like condoms and tampons. Things like work gloves, cigarette packs, things that I'm thinking of, things that wash down into the storm drains off the street. This is one of the reasons why you should never flush anything down the toilet, because those things cannot be in the system. Please do not flush anything other than your waste and or toilet paper, because toilet paper disintegrates very quickly along in the pipes of the sewage system. So plastic bags are a big problem. Water bottles are a big problem. So anything like that will be caught by the bar screen. The other way to do physical treatment, are things called muffin munchers. This is the same type of process. It's physical treatment. It's just a little bit different of a style. All right, these things actually will shred anything that gets in there that can be shred. So these things will actually turn, and it'll literally just shred anything. So let's say, I don't know, a toilet paper roll goes down the toilet and it gets into physical treatment. It'll just shred up in these muffin munchers. And I like bringing up the story of Finding Nemo. In Finding Nemo, he goes down the drain and he goes to the sewage treatment plant. That's one of the ways he gets away. But I'm sorry to say that if little Nemo would have went to the treatment plant, the first thing he would have encountered would have been probably a muffin muncher. And instead of getting away to freedom and living a happy life, poor little Nemo would have met the fate of the muffin muncher. Just to put it plainly. Okay, after physical treatment, after preliminary treatment, we move on to primary treatment. Primary treatment of wastewater. And primary treatment is a series of settling ponds. You might see these called square tanks. You might see these called grit chambers. The function is the same no matter what it's called. Primary treatment is literally settling out of the different things we don't want in the water anymore. Okay, so you got these rectangular tanks. The water sits there, and it actually moves through here very slowly. All right, sometimes it'll snake through here. Sometimes it'll move straight over top of these. Nevertheless, it takes a long time to pass over these settling tanks. Let's say a long time is about 8 hours. Okay, now on Super Bowl Sunday, we don't have that long for the water to sit there, so it'll actually go a little bit faster through this process, and you can tell that not everything is going to settle out or separate if things are going faster. Nevertheless, we want the water to take about 8 hours to go over this settling pond. So it needs to keep flowing, it needs to keep moving, but very slowly. All the while, anything solid in the water will settle to the bottom. So if you have these particulates in here, it'll settle to the bottom. So at the bottom, you'll have a collection of the grit, any particulates, and we're going to call that sludge. I'll show you a picture in a second. So as the solids settle to the bottom, greases and oils, let's make a little oil slick here, greases and oils will float to the top. So you'll get this settling out of the solids to the bottom and the greases and oils to the top. They'll float to the top. So think about things that go down the drain. Think about, you're cooking food and you use olive oil in the pan. That gets dumped down the drain. That goes into the sewage system. All the restaurants in towns, the greases and the oils and the fats, anything that goes down the drain, this is where we want to get those things separated. Okay, so let's take a look at a picture. Here you go. Here's the greases and the oils floating to the top, and then we have some sort of scraper that will scrape this stuff off, and you have to dispose of that separately. The stuff at the bottom has settled out. The water's been drained out just to look at this picture, but while the water is in there, this stuff settles to the bottom. We call this sludge. All right, and again, we'll have this sucked out, or it'll be scraped out and then disposed of in a landfill. So the point is, the water in the middle, it's cleaner. It's still gross, but it's still clean. We've settled the particulates out. The greases and oils have floated to the top. Up to 1972, this was the end of the road. This was clean water. Before the Clean Water Act, and still in developing countries, this is the way they clean their water. Just settling things out. Now, if you're following along and if you're thinking ahead, this primary treatment does a great job of settling out solids. It does a great job of floating the greases and oils to the top. The middle of the water is clearer and cleaner, but it is not free of bacteria. So that's where secondary treatment comes from. And prior to 1972 and in developing countries, the end of the road meant just settling things out. It didn't mean getting rid of the bacteria, and that's the scary part. So secondary treatment, as we move forward here, is your biological treatment. Alright, and you can even gather that that is probably one of the more important ones. I would drink water with sediment in it before I would drink water with bacteria in it. That's actually bad. Secondary treatment is known as biological treatment. And you see I have activated sludge. That's how we do it. That's the process. So from primary treatment in those settling tanks, the water will then pass into another tank, all right, where it looks kind of bubbly. You see these bubblies. And when you pass a treatment plant on the road, this is where everybody thinks the smell is coming from. But this is not where the smell is coming from. That's coming from preliminary treatment. Just because it looks sudsy and you see sewage effluent suds doesn't mean it smells. This is actually biological treatment in effect. The way it's done, what we're trying to do is clean the bacteria, the viruses, the pathogens out of the water. The way it's done is we take some of that sludge from primary treatment, that stuff that needs to go to a landfill, the stuff that's settled out. We take some of that sludge and we attach good bacteria onto it. All right, and that's what's called activated sludge. We're going to try and activate biological treatment by putting it onto sludge and adding it back into the water. All right, that's going to make the water dirty again, yes, but it's a vehicle to get good bacteria into this water. All right, so that good bacteria needs oxygen to do its thing. All right, it's aerobic bacteria. Those are the good guys. And it's put onto sludge and added into the secondary treatment containers. All right, and the reason why it's sudsy is because they need to bubble it to get air into the system so that the aerobic bacteria can breathe under the water and clean the bad bacteria. And we end up with this brown bubbling water, but that's good. That's okay. This is biological treatment. The byproduct is carbon dioxide. That's the only byproduct. And what we're doing is we're trying to get rid of those bad bacterias, the pathogens, all right, the viruses. We're also in this step getting rid of all those nitrogens and phosphorus, those things that somewhere down the road are going to produce or result in eutrophication. We're getting those out of there here. All right. Now, secondary treatment is incredibly important, and along our path, that's doing all the biological process for us. And here are those guys. These are the good guys. They do all the work. They're the ones on the activated sludge. And here's what it looks like. You'll see the bubbling and the foam. That's the aerobic bacteria doing their thing. The problem is we added sludge back into the system. After biological treatment, it is now clean of negative bacteria, but it's dirty again. So we have to settle out that activated sludge. We have to settle out that sludge that we put back in there so that the water goes from brown to clear again. All right, so we have secondary settling tanks, and they're usually circular. The common practice is to pump the water up the middle here, the dirty water, and then it goes out. All right, so it comes up this circular thing and out. And all the while, as it's coming out of this circle, it's moving very slowly. This arm right here swings around very slowly, and it'll skim any greases and oils that got through. So it'll skim that off, and it'll also stir the tank. so that while the water is passing through this settling tank, all the little particulates, any sediment that was on the sludge will settle out. So by the time the water gets to the edge and drips over, it's been cleaned again of any particulates and sediment. So you'll see water pouring over the side here, and that little like white dot is water actually pouring over and going back towards the last stage. So now in preliminary treatment, all the big stuff got out. In primary treatment, it was settled out and separated of greases and oils and particulates. In secondary treatment, it was cleaned of bacteria. In the secondary settling tanks, we resettled out any particulates that we put in, and now we're almost done. And here's a picture of the water going over the edge, cleaned. Okay, we're almost done. Some of the bad microorganisms can get past this process. Remember, prior to 1972, water was cleaned after primary treatment, so this is bonus for us. But microorganisms can get through. So we need to disinfect. But before we talk about disinfect, I want to bring this picture into play here. I want to talk about this machine. This machine is something called a filter press. And I bring it up here because it has to do with sludge. Alright, sludge needs to be collected in primary treatment. And it also needs to be collected in secondary treatment. So you get a lot of sludge. Now that sludge needs to be disposed of at a landfill. Sludge is wet. Since we scraped it off the bottom of these settling tanks, sludge is wet. Treatment plants pay the landfills to dispose of this stuff, and they pay by weight. Wet sludge would be very expensive. But if we can dry that sludge and pay less money to dispose of the same product because it's dry as opposed to wet, it would be cheaper. So the filter press is the machine that dries sludge. And that's what you're looking at. So this big giant machine is all geared upon drying sludge. And here's the sludge on the filter press. It's moving through a conveyor belt looking process, but it's all about drying that sludge so that you can pay less to dispose of the dry sludge at a landfill rather than wet sludge. Here it goes. That's the sludge. It goes into a dumpster in the back, and the landfill company comes and picks it up. I like this picture because everybody says, oh, this guy's window is open and the sludge must be stinking it. But remember, this stuff doesn't smell. It's only in that first, right when the bacteria hits the oxygen, right at preliminary treatment. That's the smelly part. I wouldn't want to jump in this or do sludge angels or anything like that, but you don't have to think about it as being smelly. Alright, I like this picture too because it shows that treatment plants must test. Alright, they're regulated by the EPA. Alright, the EPA regulates treatment plants all the time. So several times per day they'll test their water. And here you see sludge settled out at the bottom, you see greases and oils at the top, and you see clean water in the middle. Maybe they're looking at an average volume of these materials in their sample. I just like this picture because it shows you, this is basically, you're looking at primary treatment, the settling of the solids, the floating of the greases and oils, and the clear water in between. And theoretically, this clear water is not free of bacteria. So this would then go into secondary treatment. But just a nice picture of test tubes from St. Louis. Okay. Alright, so going back to our process to finish up here, after secondary treatment, we're not finished. There are some microorganisms that can get through. Alright, and those microorganisms need to be disinfected. Anything that gets back into the environment is going to be bad. So the way we disinfect is pretty much the same as the water treatment facility. We're going to disinfect using chlorine. It's somewhat controversial to continue to use chlorine, but it's effective. And as long as we allow that chlorine a chance to dilute or degas, should be safe to put in the environment, and the EPA is checking at the end of the line here to make sure that chlorine levels are safe to put this water back into the environment. So you'll see this tank, the water on its journey has to make a left-hand turn, another make left-hand turn. We're going to take a long time for this water to get out so that the chlorine has a chance to degas before it goes back into the environment. Some newer technologies up here in the top right, you see UV radiation. They're using ultraviolet radiation to clear the water of any remaining bacteria or pathogens. Okay, but that's very costly, but it's a solution to not use chlorine. So these are the methods we use to disinfect, the last step of the wastewater treatment. Okay, so that's the plant. You'll see it from an overhead view. You see a lot of settling tanks. And just take a look at this and see if you can find primary treatment, the square rectangular settling tanks. See if you can find any aeration tanks where they might use biological treatment. See if you can find any secondary settling tanks. Those would be the circular ones. And then see if you can see the creek or stream where the now cleaned water gets put back into the environment. These are all around us. You pass one every day, and this is first world technology. Alright, because in the third world, these types of expensive facilities don't exist. Alright, you're looking at wastewater that's been collected and is now literally just being drained at a landfill in Haiti. Okay, the landfill in Haiti will accept the wastewater just right on the surface, and truck after truck will come in to dump the wastewater untreated right there in the landfill itself, back out into the environment. All right, doesn't matter, it's at a landfill, it's getting into the groundwater, it's running off, it's taking poisons from other garbage that it's touching and leaching them down into the soils and the groundwater. Very ugly situation. Maybe they'll just dump it on the side of the road. Okay, in these developing countries, again, they don't have facilities like ours. They don't have the education. They don't have the know-how to care for the environment. This is the reality that we face. This is in Haiti. It's just a pool of sewage at an apartment complex. All the toilets at the apartment complex drain into a pool in the backyard and just collects there. This last picture here is a sewage pond of untreated sewage, and you're looking at right next to the ocean. Right here's the beach, here's the ocean. Alright, so it's only just a little bit, and it is going to get into the ocean. Alright, so let's take a look at a situation where we have an on-site septic system. Some of you out there might have a tank in your yard and a drain field, and this is for you. This is called on-site septic because this is on your property. Okay, on-site septic. And when you flush your toilet, when your washing machine drains, when the water goes down through your sink in your bathroom and your kitchen, alright, it all goes into a tank in your yard, and that tank is made of concrete. There'll always be a cap to that. Sometimes it's buried, sometimes it's not. It's better if it's not, because you need to access that here and there, and if it's buried you have to dig it up. But everybody should know where that cap is, because that is your only access to your septic tank. Alright, and that septic tank acts like primary treatment. If you remember, in primary treatment, the greases and the oils are going to float to the top, and the more solid particulates are going to settle to the bottom, and in the middle of the tank you'll have cleaner water. That cleaner water, will filter out into your drain field. So somewhere on your property you have links of PVC pipe with holes in them, and that treated water will go out into your yard, and it'll literally leak out into the environment. Alright, now you might be saying to yourself, what about secondary treatment? What about the bacteria and the pathogens that may or may not be in that water? Those bacteria, that bad stuff, luckily nature will do that for us. All right, if you remember, nature has ecological services. All right, some of those services are cleaning water, and in this case, the bacteria in our soils will naturally clean our wastewater for us. So if your drain field is working properly, not only will it be spilling out water that's been treated in your septic tank, but it will also be filtering and cleaning the wastewater for us as it drains back down into the groundwater table. You'll know where your drain field is. You might see a little pipe where methane or CO2 as a byproduct will degas. But if you don't have one of those pipes, you should know where your drain field is, because you don't want to be driving over it. You don't want to place a storage shed or anything on there, because these PVC pipes are delicate and they could break, and that would actually break or compromise the integrity of your drain field. Okay, here's a picture. This is a nice diagram of what your on-site septic system might look like. Just want to point out, inside the septic tank, here's where the solids will settle, and at the top is where your greases and fats and oils that you put down your drain will float to the top, and then that cleaner water will go out into the drain field and out into the environment. All right, now this is why you don't want to flush anything down your toilets or let anything go down your sink. Never let candy wrappers, don't ever flush tampons or anything like that down your toilet, because it'll clog up these drains. All right, it'll really compromise your septic system, and it can cost hundreds to thousands of dollars if anything clogs your pipes, or if you need someone to come over and maintenance that system. Okay, you can pause this video if you want to take a look at this. It's pretty much the same thing as the previous slide. Alright, here's a picture of tanks. Some people have more than one, especially if it's an apartment building or some type of 2 or 3 unit residential, but most people have just one tank. Alright, hopefully you know where yours is. Here's the access. Typical access to a tank is literally just a slab of concrete. Here you see this. My old one was square. I had one that was round one time. But when you lift off that pipe or that slab of concrete, here is the access to the septic tank. All right, inside there is all the effluent. So, like I said, all the fats float to the top. So when you pull off your septic tank and you access it, you will see the fats and the greases and the oils. That is the first thing you will see when you open up your tank. And that is the most gross thing some of you will ever see in your life. All right, but those are the greases and the oils and the fats that you probably should not be pouring down your sink, but most people do. And the idea is to get those to float up to the top. Now, depending on how many people live in your home, and how many people are flushing the toilet and taking showers and how much water you use, your septic tank can only hold a certain amount of waste over a certain period of time. So if I go back, I'll go to this picture. Over time, that sludge that settles out, all right, that'll build up and build up and build up and build up, and you don't want it to build up above your access to your drain field. If it does, your system is broken. It will not work. All right, so what people need to do is have their septic tank pumped. So someone will come out to your house, all right, take the cap off, put a pipe down here, and literally suck out the sludge. And they will put a pipe down here and literally suck out the sludge. All right, and that's what it means to get your septic tank pumped. So if you don't have your septic tank pumped, and here is this gentleman, they literally pump it into this truck and they'll haul it away for you. It costs about $200, and depending on how many people live in your house, you should have that done every 2 to 3 years. If you have a small family, maybe 4 or 5 years. Okay, but you can think about how fast or slow that your tank might fill up. Here's a picture of a drain field, and this would be buried, and you can see also why you wouldn't want to drive over this and crack those pipes. If you have any pipes sticking up out of your yard, that's the drain field. All right, that's where the CO2 or methane gases escape. But don't worry, I know those are greenhouse gases, but you're not in industrial scale. Some problems with these systems: if you plant a tree or if you have shrubs growing near your drain field, it can clog those pipes with roots. All right, and then your system will fail. If you don't pump your system will flood, and actually the waste will float to the surface of your lawn, and you'll have literally sewage on the surface of your property, or it might come into your home. Some of you remember the gray water incident at school when our pipes were clogged and waste built up and it spewed out of the water fountains on the first floor of the business apartment. So that was a situation where our school septic system failed. It was clogged. Okay, so there's a bunch of problems that can happen with septic system, with an on-site septic system, which makes it important to monitor, to understand, and take care of it, and make sure that it's working properly. Because the problems are very costly, and when you have no problems, it's a very nice system, and it's free. You don't have to pay a sewer bill. Right? There's a lot of benefits of having an on-site septic system. You just have to make sure that it's working properly, you're taking care of it. Never flush anything down the toilet that shouldn't go down. Even in public sewer, never flush anything that should not go down. Okay? All right, so being first world technologies, we have sewage treatment facilities, we have on-site septic systems, but in the developing world, they don't have such luxuries. So what do? What is one of the solutions for wastewater treatment? One of the solutions is called a living filter. Okay, this is a natural wastewater treatment process. I have a small reading about this for you. Natural wastewater treatment process, the living filter. Now, think about the ecological services that nature provides. That's what we're utilizing for this natural living filter. So, if you look here, the sewage comes through a series of pipes and it flows out and into a constructed wetland. So, if we're able to construct a wetland and use wetland plants, all right, wetland plants are those plants that provide ecological services. Right, they're going to clean and treat the wastewater for us. And you saw that in our SEEK study. Okay, in our SEEK study, it's a retention basin. It collects polluted wastewater and it treats it before it goes back onto the environment. So wetland type plants clean water for us. So if we can pump in sewage or effluent from a village in a developing country and force it through a series of wetland plants, and in fact, if we can do that twice, we are treating the water in a natural way. Okay, and this is actually free of energy. Okay, we're using gravity so that water flows through these perforated PVC pipes and into a bed of limestone gravel. If you remember in our treatment process, lime was used to buffer the pH. So the same thing here. So the limestone gravel in this constructed wetland is going to buffer the pH of the wastewater. Make sure that it's buffered. All right, and then also microbes in that gravel can start to break down the sewage, and they're then absorbed by plants, and the gravel can absorb any phosphorus, so we're collecting any nutrient runoff as well. So the limestone gravel, plays a huge part in this living filter. All right, any wastewater will continue to flow through a second pipe into a second pool where the same process is repeated, and the treated water goes back out into the environment free of bacteria, nutrients, and that water can be even recycled for irrigation, back into the village to use in flushing toilets, or to use in cooking or cleaning, whatever. So this living filter is specifically designed using limestone gravel and decomposing bacteria to filter the water, to treat the wastewater. This is a system that can be used in a developing country. They need these types of systems that are energy neutral. All right, they need these types of systems that are cheap enough, okay? But they need the education. They need these designs. We need to get over there and start spreading the word that these technologies exist. They don't have the means to build treatment facilities, and in growing countries, maybe this is a good solution for them. That's a little bit about wastewater. And water treatment, hopefully you're a little bit more educated now about where your water comes from and where your water goes after it leaves your house. All right, and the difference between first world technologies and third world situations are great. Hopefully you gained an appreciation for what we have and the systems and the infrastructure in place. All right, when you started this lecture, maybe you thought that it would really stink, but hopefully you now feel a little bit better and educated on this topic. All right, as I went through, we were using words like sludge. Hopefully now you realize what sludge is and actually that we use it in the secondary treatment process. All right. You can now stand up and go get something to eat. You have made it through another one of Mr. Burley's lectures for the AP Environmental Science classroom.